So here's a generic periodic table. Okay, so if I zoom in and look at like oxygen. All right, so oxygen right here, there's a couple numbers that we learned, right? We learned this top number right here. This is called the atomic number. Oops, wrong pen. So this is the atomic number. This number tells us the number of protons. The number of protons never changes. So atomic number is always equal to the number of protons, never changes. And it's always that top number. The other number we learned about was that bottom number. So this bottom number right here, this is called the atomic number. Or I just said atomic number. This is called the atomic mass. Atomic mass. So the atomic number up at the top is always a whole number. The bottom number, our atomic mass, is always a decimal, and that's because it's a weighted average. Okay. Now we learned about one more. Number called the mass number. So mass number you can actually get from looking at the periodic table. So mass number, let me put it up here at the top. Mass number, if you guys remember from class, is protons plus neutrons. Pretty much anything that's in the nucleus, right? Protons are in the nucleus and neutrons are in the nucleus. Now you can also find mass number by looking at the periodic table, right? If you round the atomic mass to a whole number, if you round the atomic mass to a whole number, you get the mass number, usually. Okay, but stick with the protons plus neutrons if you can. Only do this rounding part if you don't have any options. So for example, oxygen right here, right, the atomic mass down here is 15.999. If I rounded that to a whole number, it'd be 16. So I could say the mass number for oxygen is 16, at least the most common one. Okay, so let's take a look at worksheet number 3, because this is where some people were having. All right, guys, Miss Koleski here. I wanted to make a quick video. I know there were quite a few absences or people that were quarantined when I went over day 3 notes, right? So we're in the atomic structure, right? Module 1, part 1 packet. And day 3 is a little bit tricky because it starts dealing with ions. So we learned about 2 types of ions yesterday in class. We learned about cations and we learned about anions. Cations and then anions. So we learned yesterday that cations are always positively charged. Okay, they're positively charged because they lose electrons. So they lose electrons. Okay, so remember the 3 subatomic particles that we talked about. Protons, which are positive, electrons, which are negative, and then neutrons, which are neutral or have a 0 charge. Okay, so when we talk about ions, ions are anything with a charge. So anything that has a charge, either positive or negative, is an ion. The opposite of an ion is just a neutral atom. Okay, and that's what we were dealing with on our day 2 notes, right? Neutral atoms are easy, right? Because you have the same number of protons and the same number of electrons. They cancel each other out. Ions, so the only new thing we learned was we're changing up the number of electrons. Because remember, the number of protons can never change. So cations are always positive, anions then are always negative, okay? Now they're negative because they gain electrons. So it kind of sounds weird, right? Negative means you gain, positive means you lose, but just think about it. Negative anions, they're negative because they have more electrons, right? Electrons are negative, so if you have more of them, it's going to get more negative. If you have less electrons, like in a cation, less electrons, you're going to become more positive because now you have more protons than you have electrons. Okay, so we look at our periodic table. So if you've got a periodic table, problems. All right, so worksheet number 3 here. So the first couple questions we've kind of already talked about. Number 1, right? Protons, neutrons, electrons. Which one can never change? Right? Protons. So kind of explain why there. Number 2, we went over this one. What is an ion, right? We have 2 types of ions, and they become ions if they either gain or lose electrons. So just kind of describe cations and anions there. But the part that people struggle with the most, oops, let me delete that, is down here on number 3. So number 3, let me erase this line I just made. So number 3 is where we need to fill in our table. Okay, so I'm going to highlight a couple of these. You should make sure you have a periodic table out in front of you so you can kind of refer to that. All right, so on this one, you've got a couple boxes and places that you need to put some stuff. So this first example, let me pull this out so I make sure I've got the right one. So it looks like some things kind of deleted off when I downloaded this. So I'm going to rewrite some of this stuff in here. So like this first one, the element symbol kind of deleted itself for some reason. So on worksheet number 3, which is on page 12, right, you had Mercury here. Okay, so my gosh, why do I keep choosing the wrong pen, guys? All right, so we had Hg, that's mercury. It's the only metal that's a liquid at room temperature. We had this number up top, 200, and then we had this number on the bottom, 80. Okay, so we learned yesterday while we took notes that that top number is the mass number, right? This is how we write the element abbreviation. So this is the mass number on the top. It's always the bigger number. The bottom number is the atomic number that we find on the periodic table. Okay. All right, so now we got to fill in this table. So we got to figure out what is the atomic number, which we can just look at what they have written there. What is the mass number, protons, neutrons, electrons. All right, so the first one, atomic number. So atomic number is the easy one. So atomic number is whatever is on the periodic table on the top, or it's this number over here on the bottom. So it's 80. Now remember, the atomic number is equal to the number of protons. Okay, so right here, these two are always equal to each other. Okay, so I can go ahead and write 80 in for the number of protons. All right, mass number, remember. So mass number is protons plus neutrons. P plus N. But in this case, they already told us right here, right, this 200 right here, sometimes they write it for us and then we can just write it in, 200. Okay. But otherwise we would add protons plus neutrons. Okay. All right, now we have to solve for the number of neutrons and we have to solve for the number of electrons. So number of neutrons is, we got to do a little bit of math. So number of neutrons is, if you remember, mass number minus atomic number. So mass number minus atomic number. That is how you find the number of neutrons. So in this case, we've got 200 minus 80, okay, which gives us 120. So that's my answer for that one. Now on this one, normally over here on our element symbol up here in the upper corner right here where I'm highlighting, normally there's a charge there. Now if there's nothing written there, if there's no like +1, -1, there's nothing written there, then we can assume the charge is 0. Okay, if the charge is 0, then the number of protons is equal to the number of electrons. So this first one is this first one is a neutral atom. So in this case, my number of electrons is equal to the number of protons. So we just put 80. I keep choosing the wrong pen. Sorry, I keep choosing highlighter. So 80 for our number of electrons. Okay. The other ones, this is where it gets a little bit tricky. Okay, so like the next one down. So this next one down, they don't tell me the element symbol, they don't tell me the atomic number, but they do tell me the number of protons, right? They say I have 19 protons. Remember, atomic number and the number of protons are always the same, so I can go ahead and fill in atomic number. Now all I have to do is look at my periodic table and find number 18. So you're looking at that top left corner, and it looks like potassium is number 18. So I'm going to write potassium here. And I'm going to go ahead and put that little 19 down in the bottom because that's where we put our atomic number. Okay. All right, now we got to find mass number. So mass number, remember, is protons plus neutrons. So I know I have 19 protons and I have 20 neutrons. So 19 plus 20, okay, should get 39. So 39 is my mass number. All right, and then they tell us that we have 18 electrons. So on this one, I'm going to go ahead and put the 39 over here at the top in my element symbol. But now I want you to look at two things. This is what we learned differently yesterday. So I want you to look at the proton column and the electron column. Anytime you are comparing elements or ions, right, if something has a charge, you look at protons versus electrons. So ignore neutrons right now. Look at the number of protons. We have 19 protons and only 18 electrons. So if we had an equal number of protons and electrons, we would have a neutral atom, right? The overall charge would be 0. In this case, though, ask yourself, do you have more electrons or less electrons? Right? In this case, 19 or 18. 18 is smaller, right? So this meant we lost 1 electron, right? Now, when we lose electrons, we become more positive. And just think about it. You've now got more positive protons than electrons. So my overall charge for this would be +1. So when I come back over here to the element symbol, I'm going to put a +1 up in the upper right-hand corner. That's where we put our charge. So anytime you lose electrons, in this case we lost 1 electron, we put a positive charge. Anytime we gain electrons, we put a negative charge. Okay? So let's try another one. All right, let's look at, I want to try one with a negative charge. So let's go down to phosphorus. So it was right here on this -3. So I'll go ahead and write in, right? It said, okay, this is phosphorus. It's got a -3 charge. They tell me my mass number is 31. They tell me my atomic number is 15. Okay, so now I can fill in my blanks. So the first blank is my atomic number. Okay, so atomic number is right here, or you could check your periodic table. So I'll go ahead and put 15 there. We know that the atomic number is always equal to the number of protons, so I can go ahead and put 15 for my protons. All right, they tell me right here that the mass number is 31. Okay, so I can go ahead and put that in. Now let's solve for the number of neutrons. So remember, number of neutrons is mass number minus atomic number, or big number minus small number. So 31 minus 15, you should get 16. Okay. Now this one, they tell me, right, this time they tell me that the charge is -3. In order to get a -3 charge, I had to gain 3 electrons. Gain 3 electrons. Okay? So, again, anytime we're looking at charges, you compare protons and electrons. Okay? So I have 15 protons. Now that -3 charge is saying that I need to gain 3. So in other words, what is 15 plus 3? You should put 18. Okay? So negative charges, you gain electrons. Positive charges, you lose electrons. Okay? And we always write our element symbols like this, right? We put our element symbol, then we put the mass number at the top and the atomic number at the bottom. Up here in the upper right-hand corner would be any charge, right? Like for potassium. Okay? So try to do some of these yourself. We'll go over this again, and then we'll probably take a quiz on it. All right, let me know if you guys need anything else from me. Have a great day.